abstract. This formula will be about 1 inch long, but it will be robust enough to encompass the totality of the universe. So essentially, this one simple equation could give us the rules of the whole universe. And that triggered something in me. So since I was 12, I've been thinking about this. What if we could actually discover this formula? And what if it's actually very simple? And what if this formula, in a way, gives birth to the existing mathematical, uh, language that we use to understand the universe as we do currently. So essentially, my paper presents a simple formula, but a key point here is that my formula is not an equation, because an equation requires equality as a fundamental axiom. So essentially, equations, uh, it's like the equations require equality, right? But mine is a formula. It's a formula that shows a relationship between three abstractions. And these three abstractions, I believe, could give us an understanding of all transformations, all relationships in the universe, essentially.
Okay, very cool. And the three abstractions would like headlines.
Yes. So if you click on my paper above, and you go to read, it's on Google Scholar, you can read the abstract. It's very simple. It's very short, and so essentially, uh, the three abstractions are triangle, infinity, and circle. And basically, my claim is that with this simple abstraction, we could represent all the different relationships in the universe at the microscopic scale and the macroscopic scale. So we're talking about the unification of quantum mechanics and gravity.
Mm-hmm. Yep, I read through your abstract. So it's more like an epistemology that connects these three abstract ideas. Yeah.
Correct. Which to me seems to be where the solution lies, right? The solution, I understand, with modern physics, the goal is to unify these two different languages, right? The language of the big, which is obviously relativity, and the language of the small, which is quantum mechanics, right? And these two languages have a hard time marrying each other. And I think the issue is we're trying to force them together as opposed to looking for a substrate or something more fundamental that essentially we could say gives birth to these two distinct interpretations.
Mm-hmm.
So in essence, quantum mechanics and gravity and relativity theory are a different interpretation of the same fundamental rule. Does that make
Yeah,
sense?
I see where you're going with that. Yeah.
To me, it's very intuitive. So to me, it makes sense. But I think it takes a while for some people to digest it.
Yeah. I understand what you're proposing for sure. Um, does like yeah. Does this include? I can only obviously see the abstract, I think, right?
So you can click on the paper itself, and go and read the whole thing. It's on multiple platforms actually. Um, Let me know if you could do that. It's about 120 pages. So I don't know if you're
Hmm.
gonna be able to read it in real time, but you can skim through it.
Yeah. All right. Well, no, that's cool. Um, so I mean, what are are they have you kind of like shown an approach where they're mathematically equivalent?
So essentially that's why the paper is so long, because I try my best to address most of the paradoxes and anomalies that exist. Um, when it comes to reconciling these two perspectives.
Mm,
Yes. So
okay.
that's why it's called the transformational unification of quantum mechanics and general relativity, because
Hmm.
the assumption is that transformations are like the language of the universe is transformation.
Hmm.
There's something is always transforming into something else. There's
Hmm.
always a transformation going on. So the
Hmm.
question is, what governs that transformation,
Hmm.
right? How could we represent that transformation from um, I guess, a logic, like a logic that could represent that transformation? And essentially, I can just give you a quick summary here. So essentially, the entirety of quantum mechanics we could put into the triangle,
Hmm.
and the entirety of relativity theory we can put into the circle. So the thing that describes the macroscopic things, the big things, will be the circle. And then the thing that describes the small things, the microscopic things, the infinitesimal things, would be the triangle. And then the infinity is the relationship between those two scales. So if you think about the idea of transformation, think about the idea of interactions, right? There are infinite numbers of interactions happening in the universe, right? Infinite number of transformations happening. So equality is not a robust enough axiom to use to represent what's happening in the universe. Like equality is like an axiom, right? The left is equal to the right, right? And my intuition says that the concept of equality is not powerful enough concept to give us a complete picture of all the interactions in the universe. And I think that's the wall. That's the wall that physics hit. It's we're trying to essentially collapse the universe into a discrete representation, but it's not. It's a transformation that that never stops essentially, and it happens at every scale. So equality is it's like a door that prevents us from being able to represent those infinite transformations. So essentially, there's we're going to graduate from that concept, and we're going to introduce a new concept where an example that I give is this. Here's what I say. So Isaac Newton gave us uh, an understanding of the relationship between force and acceleration, right? And then Einstein sort of like zoomed out. He zoomed out from Newton's perspective and gave us a broader understanding of the universe by giving us an understanding of energy, mass, and light, right? And essentially, my theory goes a little further, a little broader, or you could say it's a lens with a higher resolution, right? That gives us a more general understanding of the universe beyond the concept of mass, beyond the concept of energy, and beyond the concept of the speed of light. So it's essentially a broader perspective, a more general perspective, or a lens that has a higher resolution. So we get to understand a deeper nature of reality beyond the current abstractions that we're familiar with, which are energy, mass, etc., etc.
Transformation. I think a lot of yeah, there's a lot of papers that are going in that direction. I definitely think it's the more promising one. So is it the same transformation or different transformations?
Is it the same fundamental transformation that governs the entirety of reality?
Hmm.
Yes. So this is like the substrate of the universe. So
Okay.
the assumption in if you can call it this, if you can call it the Einsteinian world, right? Einstein's universe requires energy to be the fundamental substrate, right?
Hmm.
And then you could say my universe goes beyond energy. My universe requires these abstractions to be the fundamental substrate. So we could derive energy from these abstractions the same way that we could derive energy from Newtonian physics.
Hmm. Okay.
So it's a broader, more complete representation of all the activity, all the interactions, and all the transformations in the universe. And the goal of physics has been to simplify the universe into one fundamental system, one language, one simple representation, right? And physics gave us uh, two perspectives, right? Which was the quantum mechanics, the perspective of the small, the microscopic, the infinitesimal, and the perspective of the large, the celestial, the cosmic. So you think of Einstein, think of gravity, think of space and time. Those are the big things, right? So essentially, the goal is to unify these two, is to find a bridge, and the bridge is beyond those concepts, because to unify these concepts, all I did was show that these two different perspectives are emergent from the same fundamental substrate, right? So it's like the baseline
via the transformations.
via the transformation.
Trans.
Essentially, correct. Everything is a transformation. Think about this, for example, like if you think about equations, right? An equation is like a picture. An equation gives you a static representation of a phenomena. Like when you say energy equal to mc squared, right? That's like a picture. It's a static representation of the universe in that moment, right? So if you assume the total number of energy in the universe is this, right, equal to and then you can get the mass times speed of light, time the mass with relationship to light, right? But that energy has to be a constant. It has to be a discrete number, right? So essentially, equations don't represent transformations. Equations is difficult to model motion or model interactions with equations, and that's why it's been difficult for us to really understand the universe, because the universe is just a bunch of interactions. It's a bunch of transformations. So how could you represent that vastness with an equation, right? You can't do that. So we have to essentially create a new language to do that. That's what I'm attempting to do.
Okay. I mean, I thought that language was like Hamiltonian systems of equations, for example.
Yes, but when I look at mathematics, like math begins with an axiom. Like the entirety of mathematics begins with an axiom or with a few axioms, and then the rest of math emerges from that axiom. So I go and I address the most obvious axiom, right? Because if you can address the axiom, then the rest of the math is kind of irrelevant, right? And one of the core
Okay.
axioms of mathematics is equality. Like if I say 1 plus 1 equal to 2, 1 plus 1 is a meaningless concept unless equality is an accepted axiom.
Yeah.
Like all mathematical calculations are meaningless concepts unless we accept equality as our baseline axiom, meaning that
Mm.
some activity on the left has to equal to some activity on the right. Right, that's an axiom. So that's a fundamental axiom in mathematics. So when I look at that axiom and I say, okay, is this a strong enough axiom to give us a, a complete picture of the universe? And the answer is no, right? Because the universe, the equality is not a powerful enough concept to model all the activity in the universe.
Yeah, I mean, it probably doesn't capture like phase changes and like all the transformations. I would, yeah, okay.
Yes.
I would agree with that.
Yeah, so that's why I don't really go into the discretized mathematics. I just focus on the axiom. I can do that, but I don't, because it's kind of it's irrelevant. Once you address the axiom, you're addressing the entirety of mathematics as a field, as a knowledge system, right? Because the math all emerged from the axiom. You begin with the axiom, and then you build onto that to create the knowledge system. It's the assumed truth, right? It's the assumption that equality is like things are equal. Equality is a real thing in the universe.
Okay, I mean, that's fine. Let's say you don't want to use the equality to describe the relationship, right? Then how are
Yes,
you going to describe the relationship?
great. So and that's what the infinity comes in when it comes to the transformation. The infinity represents the infinite number of transformations that are happening in the universe. You can call it interaction to transformations. But in that case, then we no longer discretize the we no longer have to discretize the interactions, right? Because that's why the numbers 1, 2, 3 or the equations are irrelevant in when we speak in the language of transformations. That's why we have the abstraction of triangle, or you can call it delta, which that now can represent the entire field of quantum mechanics, or the entire domain of quantum mechanics, whatever that entails, right? Quantum mechanics represents all the interactions at the microscopic scale. You can now put all that, so you could say that the infinitesimal transforms infinitely into the macroscopic, into the big, or the finite, or the bounded, or the unbounded into the bounded, the infinitesimal into the finite,
Mm-hmm.
the discrete into the continuous.
Okay. Yeah. So,
Yes.
at a quantum, if you're moving from
So
quantum,
quantum mechanics is inherently discretized. That's the whole premise of quantum mechanics. Is quantum mechanics is discretized, and relativity is continuous, and that's why it's been difficult to reconcile those two. Is that it's different languages, right? So I'm saying that you're representing the entire thing with an abstraction that allows you to now communicate between both domains. You're saying that
hmm
you can represent the entirety of the discretized language or system into this abstraction, and you're showing how it transforms into the continuous. So,
hmm
or vice versa.
Okay, yeah, that
So
makes sense.
you know what you could do actually to help you. You could take my paper, download the paper, and put it into any of the AI models that you have to give you a summary, and you can and we can go through it together. Do it in a Chat
Uh,
GPT or Claude. Just download the PDF, put it in there, and ask questions and stuff like that.
yeah, that's cool. That's cool. I'll give it a read, and yeah, we can chat about it. But it sounds, on the surface, it sounds, I mean, yeah, basically, I think the hard part will probably be just going through the numbers and how you apply the transformations and stuff, right? But
Yes. Yes.
I look
Exactly.
forward to that.
Yeah.